Hello students, welcome to my class. Today we are going to understand what is the purpose of calculus in our kinematics. So, what is calculus? So, you can see that everything around us keeps on changing. The weather changes, the cost of the products changes, the time changes, anything that is under motion, which is the ball running on the floor, changes. The population, the rate of population changes. It is all everything that changes around us. And to develop our business or to develop the things around us, you have to predict the change and you have to modify, adjust accordingly. So the calculus is that which helps to predict the change. How does this calculus relates in the kinematics? As we know, the term change is very much related to kinematics, as kinematics is nothing but motion. So when there is a motion, it is obvious that there is a change in the position of the objects. So this change can be of different types. So when there is a motion, you have to find the amount of change that can happen in the motion, which is done with the help of calculus. So the calculus is used to analyze the motion of the object. Before going into the calculus in detail, the terms that are related to calculus that we have to understand are the limits, functions, differentiation and integration. So as we said, there is a change. What is related? What is that we need to understand with respect to calculus? So change is of two types. One is the constant change and the other one is the variable change. Constant change, constant the name it means which will be with of the same value. So when the change happens, it will be with the same equal number of values. For example, when an object moves from one point to another point for some particular time period, say for example for 5 seconds, the speed, let me go in for the speed of the object now. Speed is nothing but the distance traveled by the time taken. So when the object moves in particular speed, the speed at each and every second of time will be same. That is, at first second how much speed that the object move will be the same at the time second 2 and will be same at the time second 3, which is called the constant change. The change in the aspect is same, which is at every point of time. This is called the constant change. So the variable change is what is at each point of time the speed gets varied. At point A the speed will be lesser. At point B the speed will be little higher. At point D it will be very much higher. Such kind of change is called as the variable change. At each point of time the thing will be varying. There is a change, that change level will be varying, which is called the variable change. So when you want to find the exact change value, how much on the whole, how much the change happened, you have to go for the average value in the case of the variable change. For the constant change, it is same. For 1 second also, the speed will be 5. For 4 second also, the speed will be 5. For 3 second also, the speed will be 5. So the change value is only 5, 5, 5, 5 at each time. So it is same. So you can just go for the same value as such. For in the variable case, you have to go for the average speed value. So with the understanding of the change, the first term you have to understand is the limits. So what is a limit? Limit is nothing but, as you know, it is the range up to which I have to finish, up to which I have to start, from where I have to start. This is the limit. It's just a number. So as you can see, when we throw a ball from the top point, it just drops down to the point B on the ground. We know that we are assuming that it is taking some speed and the distance it covered is 1 meter. when the ball drops down, we know that at first the ball's speed will be somewhat lesser. As it moves towards the floor, the speed will get increased. That is, it is of the variable speed. So this, we know that the time when we calculate the time taken for the ball to drop to the floor, it takes, say for example, 2 seconds. So we know that when this is happening, the ball would travel from the initial point to point B, which is midway through the path. It would take 1 second. When it takes for the whole path, it takes 2 seconds. Then for the half of the path from A to B, which it will take 1 second, and for the remaining halfway through, it is 1 second, which is 1/2 of the value. And in the remaining half of the way through, you can again split this into 2, as for this it will take 1/4 of the time, and for the remaining part it will take 1/4 of the time. Again, when you subdivide this, you can go into for the different parts to find the steps in which the ball will move to get the exact speed value at one particular time. So you can go with these steps as infinite number of steps for infinite number of times. This is time t1, t2, t3, t4, t5, as such for each and every small part of the time the ball takes to move. So this total time taken is t1 plus t2 plus t3 as of it goes till it reaches the floor. And similarly, for the steps, the speed could be 1/2 for first kind, and later it could be subdivided into 1/4, and later subdivide this 1/4 as 1/8, and again divide this as 1/16, and it goes on. So from where we start and to where we finish will be totally equal to one number, which is this whole value will be equal to always 2. It will not exceed 2, because as we know, the whole value is 2. The total time is 2, we know that, and if we split, it is 1. So if it is split, it is 1. It is again, when you split this into half, it is 1/2. Again into half, it is 1/4. Again into half, it is 1/8. So it goes on. But when you add up all the value, it will be the whole value, which is 2 simply. That number till which it goes is the limit. How much we have to split? It is still the value of the whole thing, which is simply 2 here. As of example, I've taken as 2. So when you have a cake, you're going to split the cake into half pieces, quarter pieces, 1/8 of the pieces, 1/6 of the pieces, and goes on until each one of you will get the small piece. But when you add up all the pieces, when you join all the pieces, you will obviously get the one full cake, and it will not exceed the value 1, right? This is what is the limit, the number which is called the limit here. The next thing you have to understand is the function. So for the calculus, the main thing you're going to understand is the change, is to analyze the change. So how can you understand this change? This change will be always in a particular pattern, is the basic idea. How this change happens? See, I'm going to cut the cake. It is always in this pattern, and this pattern will not change throughout the cake, right? So when something is getting changed or some object is moving, it is moving with the pattern. See, it moves like this, again like this, again like this. It goes on increasing like this. It is the pattern here, and the way in which the change happens is the pattern, and it will be always the same thing. So that particular pattern in which the change happens is called the function. For some kind of object, the pattern may be a circular change. The object will start from here, will move through this path and make a circular wave. For some for some object the change can be a square thing, which is the pattern here. So the function could be this, defining this pattern or shape, which is given as, the mathematical representation is given as y equal to f of x. So we have understood the terms, limits, functions. Next we are moving with the differentiation. So differentiation is nothing but the small change that happens on the whole. An object starts from here, it rotates, it makes some pattern and moves to the final point. This is the total change. From this point to this point is the total change. The first thing to happen is the small change. It has to move from this point to this point first. Then only it will move to this point. Then only it will move to this point. So on the whole value, I am going to take a sample value. This sample is called the small change value. So the whole change, let it be x, then the small change value is taken as dx or del x. And this change is always with respect to some time. As I said, for the first time the ball is here. After 2 seconds the ball is here. After 3 seconds the ball is here. It moves on. It gets changed. For each particular time you have to go for the change. For the small time interval, I am going to check the value of small change, which is called as the dx. So this rate of change is called as the differentiation value. Rate of change is nothing but change with respect to time. That is, see, change with respect to time, which is my function y. So it is y equal to the small change value with respect to the small time value, which is dx by dt. That is the smallest possible value of the whole part. As I said, when I have a cake, the smallest possible piece of cake I can get from the whole cake. This small piece is called as the differentiation value. I have one full cake value. I know how much to cut, and what is the small piece value is the differentiation. I hope you have understood. Let me go into the next. A simple example for you to understand. As I said of the cake, it is the square I have taken here. So when I have a square, I need to find the area. Instead of going in to find the whole area of the shape, I'm going to split this shape into two halves. And then further take this half of the part and further split this half into two halves. And again go for the half, split it, again go for the half and split it, and it goes on till I get the very smallest part of the object. And now this is my small value dx. Now find the value of, I have the whole value. It is, see, 1 meter length and 1 meter breadth. Then the area of square will be side into side, which is 1 into 1, simply 1 meter square. So I know the whole term area. I'm going to get the smallest possible value, which is called the dx, and with respect to time it is called the dx by dt. If it is with respect to time, it is dx by dt. If not, it is the smallest change value is simply represented as dx. So to find the whole area, I'm going to take the smallest part, find the smallest part area, and then add up for the next one, add up for the next one, add up for the next one. So how many of parts you have divided, add up each and everything, so that you'll get simply the whole part value. As I said, I have a cake. So I have split this cake into small pieces, 1 2 3 4 5 6 pieces, and the price of one single piece is 10 rupees. Then the price of all 6 pieces on the whole cake is simply adding up 10 10 10 for each 6 pieces, which is 10 into 6, which is simply 60 rupees on the whole. It is a similar case. Instead of finding the whole value, I'm going to split this into the smallest possible value, find the area of that, and go for the simple addition. You'll get the whole area value. Here the whole area will be 1, and the area of the shape will not change, right? When I go for the splitting also, the area of, if it is the square, area of square is 1 meter square, it is the same 1 meter square. It will not change. So when you add up the parts also, it will be approaching to one particular number, that is the exact whole value size. You have to say it as approaching. As you split up, the value will be something related to 1 point something and 0.00 something, or 0.9 something. It is approaching towards 1. If it is the regular shape like this, it is easy for us to find. You can have a question that why we need to go for splitting up. If it is the regular shape like this, it is easy for us to find, and we have the formula to find the area of a square, area of a triangle. But if it is an irregular shape like something like this, you cannot go for any formula. So in that case, you have to go in with the differentiation to split this area into smaller possible value, and then adding up with the things to get the whole value, which will be approaching to a perfect number. So next is the integration. The integration is just the inverse of differentiation. Differentiation is something you have the larger value and you're going for the sample smallest possible change value. Here integration is just the inverse. I have the smallest possible value. I'm going to expand that the whole value, which is called the integration. So the largest part obtained from the smallest possible value is through the integration, and this will not give you the exact value. It is just the approximation. As I said, I have an irregular shape. Now I know the value of the smallest possible area here. When I expand this, I'm just going to expand. How I will expand? I'm expanding by just repeating these squares. So when I repeat, on all sides, I will be getting the area of this irregular shape, but it is not covering the whole shape as it is irregular. You will be having some space left, and this area will be approximately equal to the whole area. So the major application of this integration is to get the area of any irregular shape. So as we know, any function is defined as y is equal to f of x. For differentiation, it is dx. And for integration, you're going to take that particular small change value and integrate. The symbol for integration is this one. So take the smallest value and integrate. You will get the whole possible value. As we know, see, I am taking the smallest possible value dx. This is dx. I am repeating this to n number of times. How many times? From where to where I have to expand this? It is from this point to this point, which is my limits. Say for example, from the point 0 to point 10. This is my limit. So it is from 0 to 10. This is the limits here. So this dx is my function, and from 0 to 10 is my limits. The lower one is called the lower limit, and the thing in the upper side is called the upper limit. So to better understand this, I have given an example for you. I have an irregular shape. I have to go in for the finding the area of the shape. To find that, I am going to split this into smaller equal parts like this, which is of some regular shape. So I take it and I'm going to consider this as a possible rectangles here. So when you cut this, see, you are missing out this space. So missing out this area only, you will get the whole area value. So which is why we call it as an approximation value. When you go for still smaller possible values, you will go how many number of smaller parts you split into, you will go for the higher level of exact value, so that the space gets reduced here, as you see here. Okay, so when I have a trapezoid, you can, if it is a trapezoid, or as I said, if it is a regular shape, you can go for the direct formula like this, or else you can go for the integration by splitting up this trapezoids into smaller parts. And the first smallest change is del x, and the next smallest change is again del x. This one is del x, del x, del x, equal parts. So first part is del x, then the next part will be 2 plus del x, and the next part will be 2 plus 2 del x, and the next part as it is goes on. So when you add up all these values, you will simply get the area of the trapezoid, which is similar to what we have found in the normal formula. I hope you have understood about the differentiation, integration, and the ideas of calculus here. This is all about the change happens, and it is related to kinematics. Thank you. Please subscribe to my channel.